Hello, this video is going to look at an introduction to algebraic expressions. If we think about algebra, what it really is number with a few numbers missing or a few numbers that we don't know. So algebra is number generalized. That is, if we had a lot of number statements or number equations, if we were to change one of the numbers to a letter, for example x, then what we're doing is we're replacing those numbers with an unknown. So say we didn't know what the numbers were. So if we look at this first example here, this one here, addition, very easy, we can do that quite simply. 6 plus 5, 8 plus 5, 19 plus 5. Say we didn't know that we were adding 5 to a different range of numbers. So what I've done is I've changed that 5 into an x. So I've rewritten the statements 6 plus x, 8 plus x, 19 plus x. Because we know these number statements, we can say that x in these expressions stands for 5. However, say we didn't know what these number expressions were and we just had these expressions here. 6 plus x, 8 plus x, 19 plus x. In this case, x could stand for any number or fraction or decimal. So we could replace any of these x's with any number and then evaluate it. Okay, so that's addition. Let's have a look at multiplication. So we've got here 7 times 2, 7 times 3 times 4, and then 5 times 7. So I've gone and replaced the 7's with an x. So here we have x times 2, x times 3 times 4, and 5 times x. So knowing the number statements, we can say that in these algebraic expressions, x stands for 7. So let's say that we didn't know these number statements here. If we look at x times 2, we could replace x with any number. For example, we could place negative 10 in there. So if x was equal to negative 10, this would become negative 10 times 2. Which we can evaluate. This one here, okay, if we didn't know that x was 7, x can be any number in this case. So x times 3 times 4, which would be the same as x times 12. If we look at multiplication using algebra and the way we write the algebraic expression, if we've got 5 times x, we can rewrite that as 5x. So if you see a number with a letter beside it, there's actually an invisible multiplication sign in between the number and the letter. Sometimes that letter is an actual variable. X times 2 should be written as 2x, not x2. Okay, so don't write it like that. It should be written like this, so 2x. Okay, division. So in number, we know these division statements here and we can easily do them. If we were to replace, for example, that 4 with x and just change that to 15, so 15 divided by x is an algebraic expression. We can also rewrite division or write division expressions as such. So we've got a number divided by 9. So again, if we didn't know the number statements, then these values here or these variables here could stand for any number. With division, when we are working with algebraic expressions, we change the division symbol to a division bar. So if we were to write 15 divided by x, that should be written as 15 division bar x. If we've got x divided by 9, it should really be rewritten as x over 9. So we're changing the division symbol to a division bar. Okay, now that we know a little bit about algebraic expressions, let's start using some English statements. So we're going to convert algebraic expressions to English statements. So here we have an algebraic expression here, x minus 20. So what that actually means is 20 less than x. Or, of course, if we were to read it literally, it would be x minus 20. But this is also another way of rewriting it. So 20 less than x. X plus 8, of course, literally it means x plus 8. It also means x with 8 added. Or we could write something like 8 is added to x. So all those statements would be acceptable. Okay, this statement here, or this expression here, we, of course, literally it would mean x divided by 20. Although another way of thinking about it is that x is shared, say, amongst 20 people, if there was a context related to people. So with division, it is a matter of sharing. Okay, 4 times x, of course, literally means 4 times x, but it could also mean 4 lots of x. It could also mean x plus x plus x plus x, which we know is just 4x. So 4 lots of x. And this one here, slightly more complicated, 3x minus 2. We can rewrite that as 3 lots of x less 2, or 2 less than 3 lots of x. And you should be able to go the other way as well. So if you were given, say, this statement here, 8 is added to x, you should be able to translate that as being 8 plus x, which is equal to x plus 8. So either of those would be acceptable. If we were looking at this English statement here, 20 less than x, we should be able to write x minus 20. Okay, let's have a look at substitution, which is where algebra starts to come into play. So we can also substitute a number for x and then evaluate it, meaning just find the answer. So if x is equal to 12, what is 2x minus 12? So we know 2x means 2 times x, and x is 12, so then this becomes 2 times 12 minus 5, which is 24, minus 5, which is 19. So we're evaluating, we're finding the answer. Another one here, if a is equal to 7 and b is equal to 15, what is 2ab? Now this here means 2 times a times b. So 2 times 7 times 15. So we get 14 times 15. And so 14 times 15, if we quickly do multiplication, we end up with 4, 1, so 210. So 210 there. So we can also substitute. We're changing the letters for numbers, replacing, so substituting those letters for actual numbers and then evaluating.